Greetings, fellow seekers of knowledge. Welcome to our channel, where we're about to embark on an epic 10-minute adventure through the annals of Earth's history. Today, we're delving into the awe-inspiring tale of Pangaea, the supercontinent that once united our planet's landmasses. Get ready to witness the rise, fall, and incredible legacy of Pangaea. Our journey begins with the dramatic birth of Pangaea. Approximately 335 million years ago, the Earth's tectonic forces began to shift and merge the continents, bringing them together like pieces of a cosmic puzzle. This monumental event marked the inception of a supercontinent that would shape the destiny of our planet. In 1912, Alfred Wegener noticed the same thing and proposed that the continents were once compressed into a single proto-continent, which he called Pangea, aiming all lands. And over time, they have drifted apart into their current distribution. Let's dive deeper into the forces that orchestrated Pangaea's formation. Over countless millennia, the process of continental drift brought the landmasses closer, forming a colossal landmass. Upon researching the different landmasses, he noticed that the eastern coast of South America and western coast of Africa fits together rather nicely, almost as like two pieces of puzzles fitting together in a larger picture. Another piece of puzzle, Madagascar, fits nicely around the side of the Africa, while Indian subcontinent also seemed to have a place in the larger puzzle. At that time, it seemed like an absurd idea and was criticized, but Wegener went on and published the book The Origin of the Continents and the Oceans in 1915, presenting the today's famous concept of supercontinent, which he termed as Urkontinent, meaning supercontinent in German. Later on in another edition of his book, he called the land the Pangaea of the Carboniferous, coining the term from Greek pan, meaning the entire or all, and Gaia meaning earth. It was the Latinization of this word, which became the more common word now, Pangea. The tectonic plates, acting as Earth's architects, were sculpting a world of boundless wonder. The supercontinent fractured largely along previous sutures. Gondwana, what is now Africa, South America, Antarctica, India, and Australia, first split from Laurasia. Then about 150 million years ago, Gondwana broke up. Humans did not exist during the time of the supercontinent of Pangea. Pangea formed between 300 million and 335 million years ago and began to break apart about 200 million years ago. So, Pangea broke up about 194 million years before the first ancestors of humans were on Earth. Pangea included almost all the landmass on the Earth, and it took up about 30% of the surface of the Earth, or about 57.5 million square miles. Only one small part of Earth's landmass was not part of Pangea. Those areas would have been nearly uninhabitable, with extremely hot days and frigid nights. The coast experienced seasonality, however, and transitioned from rainy weather in the summer to dry conditions during the winter. As Pangaea took shape, its landscape underwent awe-inspiring geological transformations. Mountain ranges soared, oceans ebbed and flowed, and the Earth's surface danced to the rhythm of tectonic forces. Pangaea was C-shaped, with the bulk of its mass stretching between Earth's northern and southern polar regions. The curve of the eastern edge of the supercontinent contained an embayment called the Tethys Sea, or Tethys Ocean. The Paleotethys Ocean took shape during Pangaea's initial assembly phase. This ocean was slowly replaced by the Neotethys Ocean after a strip of continental material known as the Cimmerian continent, or the Cimmerian superterrane, detached from northern Gondwana and rotated northward. Triassic Paleogeography. On the periphery of Pangaea was Cetacea, a smaller continent extending beyond the eastern edge of Angora and comprising the landmasses of both North and South China. Cetacea lay within the western Panthalassic Ocean and at the eastern end of the Paleotethys Ocean. Both oceans also contain scattered fragments of continental crust, microcontinents, basaltic volcanic island arcs, oceanic plateaus, and trenches. These island arcs and other isolated landmasses were later welded onto the margins of Pangaea, forming accreted terranes, alkaline masses that collide with continents. The splendor of Pangaea was a testament to the creative power of our planet's inner workings. Fast forward to around 175 million years ago, and Pangaea's grand journey reached a turning point. The rifts that had once brought the continents together began to tear them apart. The breakup of Pangaea set the stage for a new chapter in Earth's history. Why did Pangea break up? Scientists believe that Pangea broke apart for the same reason that the plates are moving today. The movement is caused by the convection currents that roll over in the upper zone of the mantle. This movement in the mantle causes the plates to move slowly across the surface of the Earth. However, it was only the latest in a long series of supercontinents to form on Earth, as the drifting continents came together repeatedly in a cycle that lasts about 500 million years from end to end. So at the moment we are halfway through the present cycle, the supercontinent began to break apart about 200 million years ago during the early Jurassic epoch 1 Plustered SET, 101 million to 174 million years ago, eventually forming the modern continents and the Atlantic and Indian Oceans. The legacy of Pangea's breakup reverberated across the globe. It birthed new oceans, forged mountain ranges, and influenced Earth's climate and ecosystems. The continents embarked on their individual journeys, carrying with them the echoes of Pangaea's existence. How did scientists unravel the mysteries of Pangaea? Through a remarkable blend of geological detective work, including fossil evidence, matching coastlines, and rock formations. Researchers pieced together the incredible story of Earth's past. The dinosaurs. Many iconic dinosaurs roamed the ancient landscapes of Pangaea. From the fearsome Tyrannosaurus rex to the gentle Brachiosaurus, these prehistoric giants left their mark on the supercontinent's diverse ecosystems. Pangaea's breakup wasn't a sudden event. It was a millennia-long dance of continents. Over a span of approximately 60 million years, the land masses gradually drifted apart, reshaping the face of our planet and setting the stage for the world we know today. The breakup of Pangaea didn't just rearrange the continents. It had a profound impact on Earth's climate, ocean currents, and the evolution of life itself. The interconnectedness of our planet's systems came into play, creating a complex web of cause and effect. Imagine stepping back in time to Pangea's era. The landscapes were vastly different from today, and the flora and fauna that thrived were a unique tapestry of life forms that have long since disappeared. Pangaea was a stage for an incredible drama of evolution. Did W2 and has ever crossed paths with Pangaea? Not quite. The rise of Homo sapiens came much later, but our journey through Pangaea's history offers insights into the Earth's ancient past, shaping the context for our own story. Pangaea wasn't alone in Earth's history of supercontinents. Before its time, there were others like Rodinia and Pannotia LE, each with their own stories to tell. It's a testament to the ever-changing nature of our planet's surface. A panoramic view of Pangaea's geography reveals the two major landmasses, Laurasia in the north and Gondwana in the south. These ancient continents laid the groundwork for the modern continents we know today. The question on many minds, could Pangaea ever reunite? While the exact Pangaea is unlikely to reform, the Earth's tectonic dance continues. Who knows what the future holds? Perhaps another supercontinent awaits down the line. Just as our continents were once all connected in the supercontinent known as Pangea, which separated roughly 200 million years ago, scientists predict that in approximately 250 million years from now, the continents will once again come together. If Pangea still existed, the weather of most of the Earth would be radically different. More of the Earth would be a desert because the large land mass would not allow for rainwater from the ocean to penetrate the interior, leading to a large desert. Looking ahead, the concept of future supercontinents remains a fascinating possibility. In conclusion, the concept of Pangaea, a supercontinent that existed during the late Paleozoic and early Mesozoic eras, offers valuable insights into the dynamic nature of Earth's geological history. Pangaea's formation and eventual breakup into the continents we recognize, today known as continental drift, has played a crucial role in shaping the planet's topography, climate patterns, and biodiversity. The theory of Pangaea, first proposed by Alfred Wegener in the early 20th century, revolutionized our understanding of plate tectonics and provided a unifying explanation for various geological phenomena observed across the globe. The fossil and geological evidence supporting Pangaea's existence, such as the matching coastlines of continents and the distribution of similar plant and animal species across separate landmasses, further strengthen the theory's validity. As we reflect on Pangaea's legacy, we uncover lessons that resonate with our lives today. Change is constant, and even the mightiest forces can transform. Pangaea's story inspires us to embrace the evolving nature of our world. Evidence of Pangaea's existence is all around us, from matching geological features to the distribution of ancient fossils. These artifacts offer tantalizing glimpses into the past that shaped our present. Pangaea's breakup had a profound impact on Earth's climate. As the continents shifted and oceans formed, climate patterns underwent significant shifts, setting the stage for the diverse climates we experience today. While not the sole cause, the movement of tectonic plates did contribute to the formation of earthquakes, volcanic eruptions, and other geological events. How will be Earth like in next 100 million years? Will it form a giant landmass similar to Pangaea, or will it be divided further to form even more continents, or all continents will be submerged underwater? Let's find answer to these questions another time in another space, and maybe with another you. See you next time.